Okay, I want to do a quick review of quadratics, and then this kind of leads into polynomials a little bit. We'll see how far we can get in this video. So say I want to find a quadratic function, and I know the vertex is here, and I know it goes through this point. Now, I could graph it to get a feel for it. So if I really want to, I could go, okay, when the input's 4, I'm down at what, -3, that's my vertex. And then it goes through what, 8, 10, so 4, 5, 6, 7, 8, and it's up here at 10. So obviously this thing is looking up. Now, if it goes, where's that, 8, 10, are you okay? This is your axis of symmetry. So if I go back 4, 1, 2, 3, 4, I actually know my y-intercept has to be 10 too. Now, that kind of allows me to cheat a little bit on this, but I'll do it the way other problems are done that you don't know. And then we lucked out with the y-intercept. So, well, I don't know how much we lucked out. Maybe a little bit, maybe not. All right, so basically you have to think about what this function looks like. Okay, so a function that is a quadratic has a shift. Okay, now the vertex, remember the x is always opposite of what it says, squared. The shift on the y is dealing with output, so it is what it says. So -3 because it's done after the fact. Now, notice the only thing we know is we have a positive coefficient. The problem is we don't know what number it is, right? Like, you know, is this kind of wider than normal, kind of pushed towards the y-axis? I don't know. So I'm going to put an A there because I have no idea what the coefficient is other than it's positive. And it doesn't look like it's 1/10 because this does not look overly skinny to me, right? Or compressed. So I have this. Okay, so now how many variables do I have? So in algebra, when people want you to find things, if they give you input, you usually sub it in to figure things out, right? Like, so if you're like, I don't know what to do next, well, there's this other point you haven't done anything with, and this is input and output, right? It's an x and a y, and you have the function here. So maybe I should shove this input and output into this function, right? Substitution is always a good idea. Now, here's your spot for input, right? That's your x value. Here's where the output goes. And you're like, but I don't have this. That's okay because you have 3 things you don't know. You know 2 of them. That means you can solve for A. So this is a perfect scenario. All right, so the output to the function is 10 when the input is 8. So substitution of input to find and output, always a good idea. Or subbing an input to get output, always a good idea. All right. So what do I have? 8 minus 4 is 4. 4 times 4 is what? 16. And again, this is all glued together. That is like a chunk, right? So again, isolate and inverse. How do you get rid of the -3? That's not 3a. You can't mush it with this. Apple and oranges do not go together. So add the 3 to isolate. So 16a equals, what is that? 13. Okay, so I get 16a equals 13 and divide by 16. So to me, it looks like the A should be that. All right, so I can rewrite my function. Okay, so that looks good to me. Now, what am I going to do to check my answer? Well, I could sub in this point, right? This is at 0, 10. Let's put 0 in. And if I sub in 0, I get a -4. -4 times -4 is 16. The 16s will cancel. I'll get 13 minus 3, which gives me an output of 10 there too. So that is a great idea. The other thing is, once you think you have the right function, you could graph it on Desmos and make sure it looks exactly like this, like key points are all the same. Okay, that's going to lead into something we're going to do here in a second. Okay, so let's talk about polynomials. All right, so end behavior is, these are kind of your parent functions as far as end behavior goes. X squared goes there. So anything to the even power is going to go, I would say, I call this kind of like bunny ears. It's going off to infinity. If there's a negative in front, right, it's reflective bunny ears, okay? Your go-to for the odd ones, cubics, is this is a normal cubic, right? Do you see how that's kind of like disco, like John Travolta doing a little dance there, right? Like if I have my guy And he's doing the disco, right? Okay, give him a head, I guess. So that's kind of, and see how it kind of has positive, I mean, not slope, it's not a line, but it has that positive direction, I should say. Now, so x to the fifth would be the same, x to the seventh. Anything odd is going to have kind of that disco behavior. So I'll say the official words in a second. Now, if you put negatives in front of that, then it's going to reverse. So it's going to kind of be backwards disco. It's going to kind of reflect it that way. Okay. So as far as end behavior goes, if it's to an even power, okay, that's kind of your bunny ears or reflected bunny ears behavior. What it's saying is as x goes to positive infinity, so you're going this way, your y's are going to positive infinity. As your x's are going to negative infinity, your y's are still actually, though, going up, positive infinity. Here, as x goes to positive infinity, y is going to negative infinity. As x goes to negative infinity, y is going to negative infinity. Okay, what about this one, the positive one, right? So like say x to the third. All right, again, this is more disco, right? So as x goes to positive infinity, y is going where? Well, also to positive infinity. What happens as x gets negative? Well, as x goes negative, y also goes negative, okay? So that's kind of how we would write those. That's end behavior. So if you have overall even behavior power, it's going to be one of these two. If it's odd behavior, it's going to be this. So what that means is if you have some ugly thing, doesn't matter how long it is, this tells you the behavior if you write it in descending order. So I know the end behavior, it's a positive coefficient, is going to be like this. Now, it might have bumpies in the middle. That I don't know, okay? If I have something like negative, like something like this, okay? The highest power you write in descending order is that. So I know that this is reflected bunny ears. It might have some stuff in the middle. If I have x to the fifth, maybe or 3x to the fifth plus 2x squared minus 7. All right, the overall behavior is odd, so that, and it's positive odd, so that's disco. That's my end behavior, okay? So I can tell that. All right, the other things, what else do I know? Okay, so polynomial functions. I also know that my zeros or my factors, those are your shifts. All right, so where's this guy? It has an x-intercept at -2. The factor that goes with it is a +2. This goes through 0. That's just x. There's no shift on it. This is 1, 2, 3. Remember, the shift is always backwards of what it says. This is 4. The shift is always backwards of what it says. So what do I have? 1, 2, 3, 4, 5, 6, 7. And the shift is always backwards. So these are x-intercepts. These are roots. These are solutions. These are answers. These are the factors, which again is always backwards. And I'm going to put like an f of an x up here. We're going to try to write the function. Okay. The other thing I know is that if it is odd, as far as the factor goes, if the exponent's odd, it goes through. So this goes through, so it has to be odd as far as the power goes on this. This goes through, so it's odd. This goes through, so it's odd. Now notice here, this either, some people say it bounces off. I kind of say like it touches, but it doesn't go through. Do you see that? It touches, it doesn't go through. So again, if you're like, well, I don't remember anything about this, let's just think about what we just talked about, because these are kind of your go-tos. Everyone, okay, this kind of, see how when it's squared, it kind of does that, or fourth, right? So those are kind of the touch kind. Do you see how the odd ones, those go through, right? So kind of use that idea here. I know the odd ones are going to go through, ooh, touches. That is going to be an even power on that factor. And this guy bounces or touches as well. That's going to have an even power. All right, so let's come down here. This is odd. So that's this one, right? So I could make that be to the first power. I could make it be to the third power, the fifth power. I can do whatever I want, any odd power. This guy is to an odd, so maybe I make that to the third. This is odd, maybe I make it to the fifth. This is even, and this is my 4. So again, I could do 2, I could do 4, 6, 8, whatever I want. And then this one, again, same, so I do even. Okay, now, what else do I know? Oh, is this negative or not? Well, this is disco behavior. Do you see how it goes there and then the end behavior is here? Okay, so as this goes to the positive x, it's going off to infinity. As it goes to negative, negative infinity, that's disco. Okay, so what else does that tell me? That means the overall behavior of this has to be odd. So is that true? Well, I got to check it. And you can't look at this because you'd have to multiply it out, which is ugly. So what we're going to do is just pretend like these things don't matter, like as if we didn't put any numbers in there. So this is x cubed. See how this would be x cubed? That's 6. 5 would be what? So I have 3 plus 3. This would be to the 5th power. That would be squared. And that would be what? Squared again. So what is that? 6, 11, 12, 13, 14, 15. That is odd overall behavior. So we're good there. And it's not reflected. So don't put a negative there. Okay. All right. What else do I know about this thing? I think that's about it. Okay. Oh, humps. Let's talk about humps. Okay. So changes in directions. That's the other thing we have to check. There's one here. So like local mins, right? 1, 2, 3. What do we have? 4, 5, 6. So everywhere it turns. 1, 2, 3, 4, 5, 6. Okay. So I have 6 humps or changes in directions. Okay. N minus 1 is the number of changes in directions you have. So we got the overall power. I should have written that down. What was it? 11, 12, 13, 14, 15. The overall power of this whole thing, if I were to multiply it out, would be 15. X to the 15th with a bunch of other stuff. I do not want to multiply that up. So if you take 15 minus 1, this graph can have at most 14 changes in direction. Doesn't have to, but it could have at most 14 changes. So we're good because 6 is, way less than that. Okay. All right. So again, we have to kind of play. And then what we call these things is multiplicity. It's kind of like repeat answers, like -2, -2, -2, +3, 5 times, +4, twice, +7. So again, if you're like, well, do I have really 15 answers? Well, if you count multiplicity, yes. 0 to the 3rd power is 0 multiplicity 3. -2 multiplicity 3. 3 multiplicity 5. +4 multiplicity 2, +7 multiplicity 2. Okay. But again, usually if you're like, how many answers are there? You just go 1, 2, 3, 4, 5. Okay. But the multiplicity tells you if it touches or if it goes through. All right. Okay. Let's look at this guy. How do you graph it if you're given that? Okay. It's not a trinomial, but we're going to factor it. Remember, factoring by grouping. So take out the GCF. And remember, GCF, you want to take out the negative, and then you have to take out something. So negative and that. Okay, see how this is your new GCF. So I get that. Pull that up front. And then at this point, this guy factors more. So I'm going to come over here, and I'm like, ooh, I get x minus 1. And then this is a difference of 2 squares because it's a perfect square minus a perfect square. So you get that. All right, so I am going to rewrite that now. I have duplicate factors, so I'm going to write that with a squared so I can see what is going on. Okay, and this is another problem. So, all right, so what's this guy going to look like? We'll do this on another page. Okay, well, what are all the things I have to think about? Well, n behavior. If I multiplied this out, I'd end up with an x squared eventually and an x. So my overall behavior is x cubed. So that's kind of disco-y, not reflected. Now, it's probably going to do some stuff in the middle. All right, so let's graph it. I have what? 1 and a -1. Okay, so I'm going to put a 0 here or a root or a solution there. Same here. Those are +1, -1. Okay, what's going to happen at these? Well, let's see. This guy's even power. So at a +1, it is going to touch. At a -1, it is going to go through. Okay, all right, I know that much. The overall power is cubed. So I can have n minus 1. So I can have 3 minus 1. I can have 2 humps or changes in direction. So you can't go crazy, right? There can only be 2 humps or bumps or whatever you want to call them. All right. The other thing is if you sub in 0, do you see how you know the y-intercept? It goes through 1. So I'm going to put I do know it goes through 1. Okay. So let me think about this. I want my n behavior to kind of be disco-y, not reflected. So I know it's going to go off to -infinity there. And then let's see, maybe, and it has to touch here. And that has to go off to positive infinity, right? Because it's kind of disco-y. So and I can't have too many humps here. All right. So I'm going to do that. Okay, let's see if all my requirements are met. It goes through 1. It goes through a -1. This is odd power, right? Invisible 1. So it goes through. This one touches. The overall power is x squared and x cubed. That's disco-y. No negative out front. It is not reflected. So that's how my end behavior goes. I did have the original, so I subbed in 0 for input to get the output of 1. So I know my y-intercept, and I think I'm good. That's about all I know. Okay. All right. I'm going to try graphing this one. And I have a couple more, but we'll see how much time allows. Sometimes I get kicked off. All right. So let's look at this one. Now, this one I might not get perfect on the y-axis because I am not, If I sub in 0, do you see how you're going to have 49, -2 to the 5th power, that's -32, 3 to the 7th power, I have no idea. You're going to multiply those times -4. I'm not going to do it. All right, but let's get a gist of it. -7, so 1, 2, 3, 4, 5, 6, 7. Again, your shifts are always backwards. +2. What's that? A -3. All right, so I have 1, 2, 3 x-intercepts, 3 solutions, 3 roots, whatever. Okay, this one, -7, has a multiplicity of 2. It is even, which means it's going to touch or bounce, whatever you want to say. +2 has multiplicity of 5. That is going to go through. It is odd. -3 is multiplicity of 7. That is also odd. It is going to go through. Okay. I'm not going to label my y-axis because I don't want to, it's too ugly. So we're not, this could be thousands. I don't want to do that. All right. Okay, let's look at our overall power. Our overall power, this would be 2 and 5 is 7. Overall power is 14. Okay, that tells me a couple things. Number one, it is even overall. So this is either going to be one of these for end behavior, right? They're both going to go off to positive infinity or negative. Well, it is reflected. So it's kind of like bunny ears reflected. The end behavior is going to look like this. Okay. So let me think about that. So this has to go off to infinity, right? End behavior. This does too. So, but then notice it also says it has to touch. So it has to go off to the end behavior at those points has to go off to negative infinity, but it has to touch. Okay. And then this also tells me that n-1 is how many changes in direction. 14 minus 1 is 13. I don't think I feel like putting 13 humps in here, but I could, but I'm not going to. So I'm just going to make a little bump here. I'm going to go through this one. I have no idea. Now, if you want to, you could put an extra, hump or 2 in there, but that's what I'm going to do. Now, if you graph this on Desmos, it might not look like this. Like this is just a sketch of it. It might have this overall shape. Desmos might have a few more bumps along the way, I don't know. But this is the overall behavior that we care about. We care about x-intercepts. We care about end behavior. Those are the biggies. So if you graph this on Desmos, you're like, Julie, you are wrong. Well, does it touch there, go through there, touch there? If it has a few more humps, I don't really care about it. Okay. All right, let's do a couple more. Actually, I think I'm going to make another video just because this video is getting kind of long. So I'm going to stop here and then I'll make a second video on these, which will be a quick follow-up.